So let me repeat this because I didn't have it recorded. Going over scientific notation today. Tomorrow is supposed to be dimensional analysis. I will try to go over some dimensional analysis today too. But I'll be giving out both today's homework and tomorrow's homework. So scientific notation. So 6,132, there's an imaginary decimal point right here. If you want to convert this into scientific notation always looks like this. You have some digit, a decimal point, another digit, a multiplication, 10 to something else. Probably shouldn't have used X's. So we always going to have one digit here, some remaining digits, and then a decimal out after that digit. In the other case, so doing this to figure out what the scientific notation should be for 6,132, count how many spaces it is to get after that digit. So you have to move over 3 times. So your answer will be 6.132 times 10 to the third. So if you have to move to the left, you're going to get a positive 3. So this number is going to be positive. So another example, 581. So again, there's an imaginary decimal right here. To get it after the first digit, you go over 1, 2. So this is the same thing as 5.81 times 10 to the second power, because we went over twice. 1,234,567. So there's an imaginary decimal here. You go 1, 2, 3, 4, 5, 6. So that is 1.23456 times 10 to the 6. You're always trying to move the decimal point to right here. So you count how many spots you went over. Another way of looking at it is I want to move this decimal point to right here. How many numbers are in between? You always want to move it so it's after the first decimal, or after the first digit. So like right here, we wanted to move it from here to after the first digit. There are 3 numbers in between. So 87,287. Again, there's a decimal point right here. There's an imaginary decimal point, and you want to move it after the first digit. So there are 4 numbers in between, or you can do the hopping method. So there's either you get to choose how you want to look at it. You can know that there's a decimal point supposed to be right here, and you're trying to move it here. That's 4 digits you're moving it by. So the answer will be 8.7287 times 10 to the 4th. Or if you want to do the hopping method, in which case you put a decimal down, 1, 2, 3, 4, bless you. So you hopped over by 4 spaces to make it 8.7287 times 10 to the 4th. Make sense? So when you okay, I'm getting there here in a second. So 10 to the 4th, you're raising 10 to a positive number. That means this is going to be a big number. 10 to the 4th is 10,000. Let's do 87.51. So now I don't have a whole number. I already have this decimal point. We want to take it from here and move it here. How many numbers are in between? 1. Another way of looking at it is you have to make one hop. So this would be 8.751 times 10 to the 1 power. I'm going to get to that. So another example, 343.07. So it's right here. I want to move it right here. So again, that's one hop and another hop. Or they're looking at it, there are two numbers in between. So it'd be 3.4307 times 10 to the second power. So it's going from here to here. You skip over two numbers. No. Alright, so let's go in the other direction. Let's say that I have 0.0057. Yes. So you always want it after the first digit, the first non-zero digit. So I want it to move it right here between the 5 and the 7. There is 1, 2, 3 hops I have to make, or 3 numbers in between. So it'd be 5.7 times 10 to the negative 3. 10 to the negative 3 is very small. You're raising it to a negative third power. So if you're going toward the right, you're going to have negative numbers if you're going in this direction. You're converting the scientific notation. So 0.123. Again, you want it after the first non-zero. So we need to go over one spot. 1.23 times 10 to the negative 1. So 0.00001. So you want it after the first non-zero. You want it right here. So 1, 2, 3, 4, 5. So that'd be 1 times 10 to the negative 5. Or if you had 0.03, again, I need to move it 1, 2 over. So that'd be 3 times 10 to the negative 2. You move it 2 over. I don't know why that. If you have 1.5 and you want to convert it into scientific notation, how much do you have to move zero or move the decimal point? You don't have to move it at all. So this would be 1.5 times 10 to the 0. You didn't have to move it. 10 to the 0 is just 1. By the way, if you don't know how to do exponents, if you plug this into the calculator, 10 to the 0 is literally equal to 1. 10 to the 1, or let me do it this way. 10 to the 1 is literally equal to 10. So if I did 15.1 in scientific notation, that is 1.51 times 10 to the 1. 10 to the 1 is just 10. So it's 1.51 times 10, which is 15.1. 10 to the second is 100. 10 to the negative 1 would be 0.1. 10 to the negative 2 is 0.01. 10 to the negative 3 is 0.001. Alright. Y'all good on how to convert between a number to scientific notation? It's very simple. All you have to do is count the digits where you want to move it. number of places you moved it. It's either going to be positive if it's a number greater than 1, or negative if it's a number greater or less than 1. By the way, the code word of the day is beta for remote learners. Alright, let's now convert the other way. 5.123 times 10 to the negative 2. I want you to put this in normal notation, standard notation. So what I do, first of all, 10 to the negative 2 tells you this is going to be less than 1. The negative here means less than 1. So to convert this, what I do is I pad a lot of zeros. I know that this is going to be less than 1, so I'm going to add a bunch of zeros. A bunch of zeros in front of the number. I'm then going to move that number of times. So move it 2 over. 1, 2, so it's going to be right there. 0.05123. So 5.123 times 10 to the negative 2 is equal to 0.05123. So 9.76 times 10 to the negative 5. Again, it's negative, so I know it's going to be less than 1. I know this is going to be some really small number. So I would write 9.76 and pad a bunch of zeros. I'm going to move this over 1, 2, 3, 4, 5. We'll put it right here. So this number is the same as this number. Another way of looking at this is that you need to add 2 zeros in front and put a decimal in between after the first 0. So for example, 7.36 times 10 to the negative 3. I know it's going to be 736 with 3 zeros in front of it and a decimal after the first 0. Yes. When you're going from scientific notation to standard notation. So we can count to make sure. After you do this, I count to make sure. So we're going from here. We're going 1, 2, 3. Right, we're going 1, 2, 3. So 1, 2, 3. So 5.32 times 10 to the 4th. So again, we write the number down and we're going to pad a bunch of zeros afterward. This decimal spot is going to move over 4 places. So 1, 2, 3, 4. So it's equal to 300. And cut that out. It would be equal to 53,200. .23 times 10 to the 1. So we start with 1.23 and we're going to move over by 1, making it 12.3. Sometimes you don't need any zeros because it's giving you enough spaces. So on the homework, I'm not going to grade the one that requires scientific notation. There's one problem where you had to put it in scientific notation. You should have put 2.0 times 10 to the 6 for a problem, I think, because you needed two scientific or two significant figures. So in order to do significant figures properly, sometimes you will have to write it in scientific notation. So anyone confused on this? Is scientific notation good? Like what? Like which one? Oh, this is not scientific notation. Scientific notation would be so 10 to the 6 is not scientific notation. It's technically 1 times 10 to the 6 is proper scientific notation. So let's do this together. So number 1, let's express it in scientific notation. So we need to go from here to here. So that'll be 4 digits. It'd be 4.25 times 10 to the 4th. No, because this has 3 significant figures. You wouldn't include the zeros because this has 3 significant figures. So you need to match significant figures. This has 3, so our scientific notation will have 3. Here, I need to do it 1, 2, 3, 4, 5. So it'll be 9 times 10 to the 5. Negative 5. What number 3 be? 1 times 10 to the 3rd. And again, I don't like this. This is not scientific notation. It should be 1 times 10 to the 6. 1 times anything is just that anything. So I don't know why they left that off. What would be number 4? So it's right here for decimal, and we need to move it right here. So there's 6 numbers in between. Or you would hop 6 times. What about number 5? So we need to do it after the 6, so we go over 0, 0, and 6. What about number 6? For going backward, it's slightly more difficult. I always write. I usually how I personally do it is I guess and then correct myself. If I added an additional 0, I'll erase it. If I need another 0, I'll add it. That's just personally how I do it. So after writing the number, I double check. I went from here. So I just basically after I write the number, I reconvert it back into scientific notation to see if I'm right. So I need to go from here to here. That's 3. That's correct. So what would be number 7? So again, to check if you're right, convert it back. You need the 0. You need this to go after the 1, so that's 3 spots. Number 7 would be what? 7.0. This has 2 significant figures, so your answer should have 2 significant figures. And number 9 is improper. It should be 1 times 10 to the 6. It would be 1 million. And then what would be number 10? The first one, the easier one. So 1, 2, 3, 4, 5. Yep. So my plan of the day was only scientific notation. My plan for today was to hand out this, give you most of the day, rest of the class period to do it. It would have been, I would have expected probably a lot of you to actually finish it in class. Unfortunately, I think y'all got scientific notation down, and it's probably better if I move on to dimensional analysis. Do y'all agree? Do y'all think y'all got this down? Yes, for number 15, for example, so looking at your homework, for number 15, just multiply them together, and it says perform each of the following operations using scientific notation. Your answer should be rounded to the 10th column in each answer. I think last year I modified this, but I don't really care. I think I said to use significant figures on this. But yeah, just multiply these together and put your answers in scientific notation. So yeah, 22 would be adding. You just add the numbers together. You can use a calculator to do it. You can use your phone. Just make sure to record your answer in scientific notation. So your calculator might give you a number that's not in scientific notation. Put it back. I think it's straightforward. I'm not going to be too concerned with scientific, with rounding and significant figures on 15 through 25. Any questions before I move on? All right, dimensional analysis. I'll go ahead and pass out the homework before I forget, because I'm sure I'm going to be teaching to the bell. This was supposed to be a full day's lesson. Yeah, that was supposed to be tomorrow's homework. It's 27 problems. Are going to take a little bit to do. Yeah. Yeah. I want y'all though to do it in the way I do it. So let's see if I can invent a problem. One apple is equal to 2 pears. 7 oranges is equal to 5 pears. 20 grapes is equal to 4 grapefruits. And 2 oranges are equal to 1 grape. If you had 5 apples, how many grapefruits would you have in equivalent? So how many grapefruits are equal to 5 apples? So 1 apple is equal to 2 pears. 7 oranges are equal to 5 pears. 20 grapes are equal to 4 grapefruits. And 2 oranges are equal to 1 grape. Me, I can look at this and do the math quite easy. There's a simple rule. We start with what we're given. So let me write down. How many grapefruits are equivalent to 5 apples? How many grapefruits are equivalent to 5 apples? Another name for dimension is unit. So units are called dimensions. So what you do is you begin with what you're started with. Apples. And we're going to do some unit conversion. I make this grid. And I'm going to eventually try to get to grapefruits down here. I want grapefruits, the only thing left. So let's do some conversion. I can convert apples to pears. So what you do is I have apples here. What happens when you divide like an apple to an apple? What happens when you divide like meters per meter? They cancel out whenever you divide something by itself. So you go put apples on the bottom, and you're going to put pears on the top. So it is 1 apple to 2 pears. So we put apples to cancel out this unit, and now we're in pears. So apples divided by apples. So 5 apples is equal to 10 pears. Because we can cancel out apples. Pears, we can convert pears into oranges. So we know that pears and oranges are equivalent. We can put pear on the bottom, oranges on the top. So it is 5 pears to 7 oranges. Pears cancel out, giving you oranges. Oranges to grapes. So to get rid of oranges, we put oranges on bottom, grapes on top. So it is 2 oranges to 1 grape. And lastly, we can put grapes on the bottom and grape fruit on the top. So it is 20 grapes to 4 grapefruit. So pears cancel out, oranges cancel out, grapes cancel out. So we're left with 5 times 2 times 7 times 1 times 4 over 1 times 5 times 2 times 20. Multiply the entire numerator together. So the entire numerator multiplied together, or everything in the top row, is 280. And then multiply everything in the bottom row. 200. And that is equal to 1.4. And we're left with only the unit grapefruit. This setup where I'm canceling out units tells me the correct order. Do I need to divide by 5 or do I need to multiply by 5? Do I need to multiply by 20 or divide by 20? You put 20 on the denominator so it cancels out these scrapes, these units. So this is a technique for really going in and figuring out quickly, do you need to multiply the ratio or divide by the ratio? I really recommend you doing it this way, as once you get this down, you don't have to worry about equations. You don't have to worry, do I need to multiply or divide whenever solving for density? For example, density of something is equal to 5 grams per milliliter. Mass is equal to 10 grams. And I want you to find a volume of that. Now what you can do is you can look and do the algebra. Density is equal to mass divided by volume. Solving for volume, volume would be equal to mass divided by density. So I put in 10 grams divided by 5 grams per milliliter, and I get an answer of 2 milliliters. You had to use algebra to do this, right? Let's start with what I'm given. I am given 10 grams as my mass. I am trying to convert 10 grams into some volume that is milliliters. So I would draw my little grid. I would start in 10 grams. And I'm trying to get in milliliters. So I would put in that my ratio is 5 grams per 1 milliliter. That's what this density says, 5 grams per 1 milliliter. Grams cancel each other out and I'm left with milliliters. So it'd be 10 divided by 5. Milliliters are 2 milliliters. I am converting units to get to my answer without using algebra. Another example, I have a mass. I'm looking for a mass in grams. Better yet, I'm looking for my mass in kilograms. I tell you the density is equal to 2.5 grams per milliliter. And we have a volume of 200 milliliters. So again, you can use algebra to solve for this. Density is equal to mass divided by volume. You're solving for mass. Mass is equal to density times volume. Density was 2.5 times 200 milliliters for the volume. So that gives me an answer of 500 grams. But I want my answers in kilograms, so I would divide by 1,000, that is 0.5 kilograms. So that's my answer using algebra and conversion. If I wanted to use dimensional analysis, start with what I'm given. I'm given 200 milliliters. And I want my answer somewhere over here in kilograms. So first I'm going to convert this into grams by using this ratio. It is, so I want milliliters to cancel out, so I'm going to put milliliters up here and grams on top. So it's 2.5 grams per 1 milliliter. I know So again, I'm going to need to convert kilograms. So I'm going to want to cancel out grams and make it kilograms. I know there is 1,000 grams in 1 kilogram. So milliliters cancel out, grams cancel out, and my answer is in kilograms. So it'd be 200 times 2.5 times 1 over 1 times 1,000. The ones, you can ignore them. So it's basically 200 times 2.5 divided by 1,000, which gives me my answer, 0.5 kilograms. Does that make sense? Yeah, I'll do one. So code word of the day is beta. I don't know if I mentioned it for all mountain learners. So how many seconds are in 5 hours? So dimensional analysis, we start with what we're given. We're given 5 hours. And we draw our little grid. What we want to do is cancel hours and get seconds. We want to convert the unit's hours into another unit. So, best deal for here is to go to minutes. How many minutes are an hour? So we can either do 60 minutes per 1 hour, or we can do 1 hour per 60 minutes. So we're either going to put this in next or this in. We want to cancel out hours. So we want hours on the bottom. So that'd be 60 minutes per 1 hour. Hours cancel out, we're now in minutes. We need to convert minutes into seconds. Again, we can either put 60 seconds in 1 minute, or 1 minute per 60 seconds. We want to cancel out the minute, so we make minute on bottom. So 60 seconds per 1 minute, so that the minutes cancel out. So 5 hours is thus equal to 5 times 60 times 60. And technically it'd be divided by 1 times 1, but that doesn't do anything. You can often just ignore ones. So 18,000 seconds. So you make $5 an hour and work 8 hours a day. How much money do you make in 10 days? So I'm trying to convert days into dollars. So I'm going from days into dollars. In order to do that, I need to first convert days into hours, how many hours that I work in total, and then hours into dollars. So begin by starting. So start with what number you're given, and then we're going to do a conversion factor. We know that there are 8 hours in a workday. So again, you can put 8 hours per one workday, or one workday is 8 hours. We want to cancel out days, so we choose the one where days are on the bottom. So it's 1 day, you get 8 hours of work. We know that it is $5 per hour, so we want to cancel out hours. So it's $5 for 1 hour. So now days cancel out, hours cancel out, and all you're left with is money. So again, you multiply the numerator and divide by the denominator. So that'd be $400. Yeah, so this would be, the answer would be 10 times 8 times 5 divided by 1 times 1. So it would be, the top numbers are 400, the bottom numbers is 1, so this equals 400, and you're only left with dollar signs, so it's dollars like that, sorry. So your top numbers all multiply together, your bottom numbers all multiply together. So top numbers would equal 400, bottom number 1, and then you just divide. Make sense? Let's do an example somewhat like number 4. So you work 500 minutes in a day. How many hours per day is that? So we're trying to convert minutes minutes per day into hours per day. So start with what you're given. That's 500 minutes per 1 day. And we're trying to convert minutes into hours. So to cancel out minutes, I put minute on the bottom. There are 60 minutes in 1 hour. The minutes cancel out. So that would be 500 divided by 600. So that'd be 8.333. And it's hours per day. It's only 2 units left. Hours per day. I'll try to release a video this afternoon that goes into more detail. I'll try to find unique problems too.